Hello. Cybersecurity training is about solving practical cybersecurity tasks in computer networks. In general, hands-on exercises train higher order thinking and problem solving, which is also a similar goal to programming courses, for instance. But there is one big difference. Cybersecurity is process-oriented. The goal of trainees is, for example, to scan computer network, exploit a vulnerability, or to repel a cyber attack. We have no tangible output like code that would be assessed or analyzed. Therefore, it's difficult to check the progress of trainees or identify trainees being in troubles during the exercise. And here, visual analytics can significantly help. However, it's a quite new application domain. Nobody knows where exactly and how the visualizations can help. Of course, there exist specific visualizations for particular tasks, but the global view of the state of this domain was missing. So we try to map this state and provide generic guidelines for visualizations in this domain. Well, the first step was the unification of cybersecurity training programs. There is plenty of diverse approaches used worldwide to train practical cybersecurity. We noticed that every training, regardless of its type, consists of three basic phases. First, the training has to be somehow designed and prepared during so-called planning phase. Then it's organized. We say that the training is executed, and then the results are used for reflection. Reflection is important for both trainees to learn from their mistakes and for organizers to continuously improve the impact of future training sessions. Other people involved in these phases significantly differ across various training programs. We were able to classify them into several distinct roles. However, as you can see, these roles are not completely independent. They form a hierarchy. Besides trainees, who are the primary subjects of training programs, of course, there is a lot of other people involved in the organization of training sessions. Usually, there are tutors or judges who supervise the training session. There can be sparring partners of trainees like attackers. And because training sessions are usually organized in complex distributed environments, referred to as cyber ranges, then there can be also operator of such cyber ranges involved in the analysis of the data. All these participants can somehow benefit from the analysis of training, but not only direct participants of the training sessions are interested in the data. Another important group are designers of training programs who invent the training content and who want to learn how much training fulfilled their expectations. So, having such classification of user roles, we could use them as personas for the specification of visual analytic approaches. Putting together the lifecycle, user roles, and data available in different phases, we were able to define areas where visualization techniques can help. The classification is hierarchical. At the top level, we distinguished between visualizations for situational awareness and post-training visual data analysis. In general, design rules for situational awareness are very specific because they have to reflect the fact that they are used at runtime and they serve like monitoring tools for rapid decision making. On the contrary, post-training analysis is used for the retrieval of, let's say, deeper inferred knowledge. The second level divides visualizations according to specific visualization goals of involved user roles. Trainees need to know current state of the exercise and get insight into the cybersecurity processes. They ask questions like, is my server accessible for users, or did I protect a host successfully? Corresponding visualizations tend to be demonstrative. They should provide identification of semantics of network hosts, state of links, and other like storytelling features. Organizing participants, especially tutors who supervise the training, have to know the state of the training session, whether there are some students stuck in some task and so on. Supporting visualizations have to be easy to decode because supervisors have to pay attention primarily to participants, and they have to provide an overview of the training session with the identification of possible troubles so that supervisors can intervene in time. From the learning point of view, very important is a person-centered feedback provided to trainees just after the training and enabling them to become aware of their mistakes or suboptimal steps performed in solving tasks. Similarly, supervisors typically learn how they perform during the training, whether they intervened in time and so on. Therefore, retrospective person-centered views of the training development and results are necessary. Continuous improvement of training programs and increasing the impact of training on learners is the ultimate goal for any long-term education. Training designers should analyze whether there are some flaws in the tasks, study and compare difficulty of training programs, and so on. There is not much done in this area, and we consider this topic very important and interesting. Data captured during the training can be also or used to learn something about the behavior of trainees. For example, how much members of team cooperated and how it affected final results. Again, this is a quite open and very interesting area where behavioral and process models could be supported by analytical visualizations, and we already started to tackle this topic. The last category is a bit special because it's related to the infrastructure in which training programs are realized. As cyber ranges are very complex, unreliable, and their operation is costly, it's vital to analyze their features and bottlenecks from data collected during the training sessions. Okay. What I have presented were just examples. In the paper, we described the third level that represents even a finer-grained categorization of analytical tasks. For each of these low-level category, we define the roles that can benefit from the visualization, their analytical goals. We discuss use cases, constraints, or requirements reflecting possible visual analytics approaches. We have enough space here to explain them all, but I can provide at least one example for personal reflection on trainees. In this particular category, we specify that the utilization of this kind of analytical visualizations is just after the exercise, when trainees still remember details of their behavior, made decisions, and conducted actions. And providing this feedback as soon as possible means that the analytical visualizations have to be generated automatically from data. In all categories, we provide examples of analytical hypotheses. In this case, is that trainees are typically wonder what they did wrong in particular task, where they lost most points and why, or how they performed compared to other trainees. We also aim to summarize current state and emphasize design rules or similar like takeaway messages that would be useful when designing new visualization tools. Here, the obvious feedback has just the form of simple scoreboard or limited informal comments prepared by supervisors. And we claim that more valuable visual feedback should be person-centered, providing view of trainee's behavior during the training session and comparing his or her behavior with other players. Uh, it has to be easy to use because the exercise is often exhaustive, and even after such exhaustive training, the participants should be still willing to and motivated to interact with the visualization and learn even more from the exercise. We provide examples of existing visualizations, if some exist, of course, but in general, as this is quite new application domain and the most of the categories that I presented here are either not covered at all or only basic or very specific cases are covered, and there is definitely a huge space for further research. To conclude, our conceptual model can serve as a framework providing a basic guidelines for the development of analytical visualizations for various fields of cybersecurity training. Thank you for your attention, and I'm ready to answer your questions.